Hi everyone! In this video we're going to look at how to solve system of equations by substitution. In the last video we solved systems by graphing, and we learned that some of the limitations of graphing. Well, one of them that we talked about is that if your solution point is not on a lattice point, it can be difficult to know exactly where it is. You might have to do some estimating. Also, what happens if your solution is a very big number? What if it's, 1,000 comma negative 274? I don't really feel like graphing that. So graphing certainly has its limitations. Solving by substitution is one of two algebraic ways to solve a system of equations. So that means that I don't have to graph at all. I can just solve it using algebra, and I'll be able to get my correct answer. So first I want to go over what the steps of solving by substitution are. So let's do this. I want to go over them one by one. So, and before we talk about this, some things in math are hard to put into English, which is weird, or hard to put down in words. It's so much easier to see them actually done. So if any of these steps don't make sense to you, as we go through it, I think that'll help a little bit. But I tried my best to just write them down in words. So first thing you want to do, you want to get one of your variables alone in one of your equations. You do not always have to get y by itself or always x by itself. Pick one of them, it doesn't matter, and only in one of the equations. That doesn't matter either. You don't always have to deal with the first equation. You pick. And I say choose wisely, because a lot of times one variable is much easier to get by itself than the other. So why not pick the easier one, right? So we'll talk about going through that. Second step. Now this is what I'm talking about. It's easier to see this done than to read it. But you're going to substitute in what that variable is equal to into the other equation in place of that variable. We'll go through that in a minute. Then we're going to solve the equation. That's going to give you one part of your answer. Remember, the solution is an ordered pair, x comma y. So after step 3, you'll either have x or y. So you'll have the first one part of the answer, you need the other part. So you're going to use that answer in step 4, use that answer to solve for the remaining variable, because you would have found either x or y right here. So whichever one you don't have, you're going to solve for that in step 4. And then, once you solve for it, now you have x and you have y, so you give your answer as an ordered pair. They're always listed as an ordered pair, and then it's always a good idea to check that answer. Okay, so let's go through one by one. We're going to start off with some easier examples, and then we'll move on to some that are a little bit more difficult. So, let's see if you can see both sides. Move this over a little bit. Okay, that looks good. So step 1, I want to get one of the variables alone in one of these equations. Well, lucky for me, y is by itself in this one and in this one. So step 1 is actually done for me. So I'm happy about that. Step 2. Alright, so here, y is equal to 2x plus 1. 2x plus 1 is the exact same thing as y. That's what that equal sign means. So what I'm going to do is, in this other equation, instead of writing y, I'm going to write, well, y is equal to 2x plus 1. So that's going to look like this. So instead of y, I write 2x plus 1 equals 3x minus 4. That's the substitution part. That's why this is named as it is, because I just substituted in this value into that equation. So now if you look what I have, I only have x's. I can solve for x now. So I'll go ahead and do that. I have to move this 2x over there because I need to get the x's together, so I'll subtract 2x from both sides. So now on the left I just have 1. 3x minus 2x is just 1x, but we just write x. I still have a negative 4. And I'm almost done. I got to get x by itself, so I'll add 4 to the other side. So 5 is equal to x. So I've actually just done step 3. I solved the equation, and now I have one part of my answer. I know what the x is. Remember, my solution will always be an x and a y. I just got to figure out what the y is. So if you look at part 4, use that answer to solve for the remaining variable. I can go right back to this other equation, and now that I know what x is, so this is where, let's see, I'll draw it like this. I'm just going to bring down y equals 2x plus 1. Same equation, I'm just writing it down here. But now I know what x is. I know that x is 5. So I get to put in a 5 for x. So y equals 2 times 5, because I know what x is, plus 1. So 2 times 5 is 10, plus 1 is 11. So now I have x and I have y. So therefore my solution is the ordered pair 5, 11. Make sure you always put the x first, then the y. It may happen. It'll happen plenty of times where you just happen to solve for y first instead of x. No big deal. Just make sure in your answer you write it as x, y. Alright? So let's try same idea down. Oh, and then we should check it. So if we plug that in real quick, let's see, I'll do it over here. Alright, check. So y equals 2x plus 1. If I take 5 for x and 11 for y and plug it in, it had better work there. Otherwise, I had the wrong point. So, is 11 equal to 2 times 5 plus 1? Well, 2 times 5 is 10 plus 1. 11 is equal to 11. So I know it works in the first one. Now I got to try the second one. You always have to try both. So again, let's plug in 5 and 11. Is 11 equal to 3 times 5 minus 4? Well, 3 times 5 is 15, and 15 minus 4 is 11. So, since I have verified that it works in both of my original equations, I know for a fact that that's my answer. Okay, so let's try our next problem down here. I'm going to go through the same steps, but now this one's a little bit trickier. I want to get one, remember step 1, get one of the variables alone in one of the equations. So, let's see. Notice I say choose wisely. So if I look here, I would not try and get this y by itself. Look at all the work you'd have to do. You'd have to move the x over and divide everybody by this -3. Why would you do all that work when I could very easily just add 3y to the other side? Look at this equation though. I could have just as easily subtracted x to the other side and gotten y by itself. Or I could subtract y to the other side and have x by itself. None of the, I mean, those are all equally as easy, so it doesn't matter what you pick. I look at this and the first thing I see is I want to move that 3y over. So I'm going to go that route, but it would not matter. We would all get the same answer even if you chose to get one of these variables by itself. You would get the same answer if you chose to get this y by itself. You would just do a lot more work, and I don't want to do that. So we'll add 3y to both sides. So I have x equals 6 plus 3y. So now I have one of the variables alone in one of the equations. That's exactly what I want. So I'll do that same thing as in the last one. X is equal to 6 plus 3y. So I'm going to go to my other equation, and instead of writing x, I'm going to write 6 plus 3y. So that's going to look like this. 6 plus 3y plus y equals 10. This is an equation that I can solve for y. So let's simplify. 3y plus y is 4y. And now I can subtract 6. So I get 4y equals 4. Divide both sides by 4. And it turns out that y is 1. Great, so now I have one part of my answer. I know that y is 1. I just have to figure out what x is. I can go right back here, and now that I know that y is 1, 6 plus 3 times 1. So that would be 6 plus 3 is 9. So my solution, x has to go first, so it's 9, 1. Okay? So that's the idea. You do not have to get y by itself all the time or x by itself all the time. It doesn't matter. Go with whatever is easiest. Okay, let's try our next example. Okay, so looking at this one here, Get one of the variables alone in one of the equations. Well, hey, look at this. Y is already by itself here, so step 1 is done for me. I'm just going to take this and plug it in over here. Now, I purposely set this problem up because this is the type of problem that so many kids mess up. If you think you have the hang of this and you want to pause it and do it on your own and then go ahead and play and just see if we end up with the same answer, because I'm telling you, kids mess this one up all the time. So I want to really highlight how to do this one properly. Okay, so y is equal to 3x plus 1. That whole entire thing. I'm going to write 3x plus 1 here instead of y. But there's a problem. I'm subtracting y. I'm subtracting everything that y is. So when I plug this in, I really have to do it like this. Minus everything that y is, which is 3x plus 1, equals negative 7. I know, this is confusing because you want to get in the idea that you're subtracting everything that y is, so you need these parentheses. Why is it so important? Because you're going to distribute that negative to both. And that is where kids mess up all the time. They just write x minus 3x plus 1, but they don't have these parentheses, so they never distribute that negative. Alright? That is crucial. If that were a plus, when it's plus, you get away with murder because then it doesn't matter. Here, though, you have to distribute that negative, and it's going to cause you to lose so many points if you don't pick up on it. So please make sure that you're very careful when you are subtracting. Alright? But now I do only have x's left, so let's go ahead and distribute that negative. So now it's x minus 3x minus 1 equals negative 7. If you tried this on and you have a plus right there, you're not distributing that negative. You have to be careful. Okay, but now I can simplify this. X minus 3x is negative 2x minus 1 equals negative 7. Let's add the 1 to the other side. Negative 2x equals a negative 6. Divide both sides by a negative 2. And I got x is 3. Okay, so great. That's part of my answer. I can just go back over here. Y equals 3 times, now I know that x is 3. So y is going to be 9 plus 1 is 10. So my solution is 3, 10. Okay. So, let's just double check, because I feel like some of you don't believe me, because some of you are going to insist that I'm wrong with this business, but I've been doing this a long time, so let's just do our check over here real quick. Y equals 3x plus 1. Let's see. Y is 10. Is 10 equal to 3 times 3 plus 1? Yes, 10 is equal to 10, so I know it works in the first equation. Let's try the second. X minus y equals negative 7. Let's see. Is 3 minus 10 equal to negative 7? You bet it is. So, 3, 10 has got to be our answer. And if you didn't get that, double check that you didn't mess up right here. Or, another, believe it or not, very common mistakes with these are just adding and subtracting your negatives. So double check that you didn't add or subtract wrong anywhere. And that'll hopefully give you an insight if you didn't get this one. Okay? So now I want to do, from the last video where we were solving by graphing, I want to solve the same problems and show you that we're going to get the same answer whether we solve by graphing or by substitution. So, here we have these two. I want to get one of the variables alone in one of the equations. They're both by themselves, so it doesn't matter which one I pick. Let's take this, and I'm going to plug it in for the y right there. So I'm going to write 1/2 x plus 2 equals 3x minus 3. Now, here's a fancy little algebra trick that you can do to make your life a little bit easier. I don't particularly want to deal with fractions. It's going to make everything kind of messy. So what I can do, since I only have this one fraction here, I can multiply the whole thing by its denominator. If I had multiple fractions, remember I would want to find the least common multiple of the denominators and multiply the entire equation by that number. But here, I can multiply the whole entire thing by 2, and I won't have a fraction anymore. So 2 times 1/2 x is just 1x, so we just write x. 2 times 2 plus 4. 2 times 3x is 6x. And 2 times negative 3 is negative 6. So this is a little bit easier for me to deal with, so now I can just solve for x like I normally would. 6x minus x is 5x minus 6. I'll add the 6 to the other side. 10 equals 5x, divide both sides by 5. So now I know that x is equal to 2. If I plug that back into our other equation, 1/2 times 2 plus 2, well, 1/2 times 2 is 1, and 1 plus 2 is 3. So my solution is therefore at the point 2, 3. And I just want to show you from our last video, here's the graph of those same two equations, and we got the same solution, 2, 3. Okay, so that's another way that you can check. If you want to check your work by solving by substitution, you could graph it and see if you end up with the same thing. You can take this point and plug it into each, check and make sure. You have a lot of options here, so no reason that we should get them wrong, because we can check them like 10 different ways. Alright, so there's that one. Let's try the next one from the video, or from the last video. We'll solve it using substitution, and then go back to our graph and see if we got the same answer. Alright, y equals x, y plus 1 equals 4/3 x. Okay, get one of the variables alone in one of the equations. Well, both x and y are alone in this first one, so why don't it doesn't really matter what we do, why don't I just take, I know y is equal to x, so I'll replace y with x right there. So now I have x plus 1 equals 4/3 x. Again, I have a fraction. I don't necessarily want to deal with it, so I'm going to clear my fractions. What would I have to multiply by in this case to clear the fractions? Hopefully you said 3, because that's my denominator. So multiply everybody by 3. And we get 3x plus 3. 3 times 4/3 x is 4x. And now all I have left are x's. I'll subtract 3x from both sides. 3 equals 4x minus 3x is 1x, or just x. So now I know that x is 3. So I can go back over here and figure out what y is. Well, since y and x are equal to each other, then y must also equal 3. So my solution is 3, 3. Is that the same when we graphed it? Well, how about that? It sure is. Y equals x, and we had y plus 1 equals 4/3 x, and the solution is 3, 3. Great. Okay, let's try our next one. Just draw a line here. Now, in this one, neither of these are alone. But remember what we said about choosing wisely. There's one variable in one of these equations that's going to be much easier to get by itself than the others. Can you pick it? Hopefully you said that x, because all I have to do to get this x by itself is subtract 2y. If I tried to get anything else by itself, I'm going to have to do more work than that. And I don't want to. So let us simply subtract 2y from both sides. So now I have x is equal to 3 minus 2y. Great. So now I know that x is the same thing as 3 minus 2y. So I'm going to go to this equation and plug that in for x. Now, I'm doing 2 times everything that x is, so I have to use those parentheses again. So I want to do 2 times everything that x is, 3 minus 2y, plus 4y equals 6. And now I have an equation that only has y's in it. So this I can certainly solve for y. So we'll distribute that 2. Okay, and negative 4y plus 4y is just 0, so I get 6 equals 6. What do I do now? Well, believe it or not, this was supposed to happen. If we go back real quick and I just show you what this graph looked like. So here was the graph of these two. Remember that we had gotten infinite solutions because they're the exact same line. When we had rewritten them into slope-intercept form, they're exactly the same. So, when you are going along algebraically, and you end up with something like this, that's true. 6 does equal 6, but I can't go anywhere from here. I'm kind of stuck. So, if you have something that is true, that means that you have infinite solutions. So let's say true statement indicates infinite solutions. Because the lines are, we have a fancy word when it's the same exact line, one on top of another. We call it coinciding. So in other words, it's the exact same line. So just double check that you didn't mess up algebraically. You may, so if you're doing this and you actually want to verify that you just didn't mess up somewhere, you could rewrite them both in slope-intercept form and verify that they are in fact the exact same line. So we have infinite solutions. Anytime you get something like this, you could get 0 equals 0. You could get, negative 5 equals negative 5. If it's a true statement, you would have infinite solutions. Okay, so let's check our next one from the last video. Okay, now this one, if you remember, y equals 5 and y equals 4x minus 3, guess what? I already gave you part of the answer. You know what the y coordinate is. You know it's 5. All I have to do is figure out what x is. So I'm actually already up to step 4. I'm going to take this answer and plug it in over here and see what x is. So that's not so bad. So I get to take 5. 5 is equal to y. So I just write 5 equals 4x minus 3. And I can solve this for x. I'll add 3 to both sides. 8 equals 4x. Divide both sides by the 4. And I get 2. So my solution is just 2, 5. And let's verify with our graph. Is that what we had before? It's down here. Yep, 2, 5. Because remember, y equals 5 is that horizontal line. And then we had our other graph, 2, 5. Perfect. Okay, and let's try this one down here. Okay, so step 1, get one of the variables alone in one of the equations. Well, that's done. I have y equal to 1/3 x plus 6. So I'm ready to go there. I'll take this, and I'll plug it in for y over here. So that gets me negative x plus 3 times the whole thing that y is. So it's all of this. 1/3 x plus 6 equals 9. And now all I have is x's, so I can solve for that. I'll have to distribute this 3. 3 times 1/3 x is just 1x, but we just write it as x. 3 times 6 is plus 18 equals 9. Negative x plus x, I just cancel each other out, so I have 18 equals 9. What? 18 does not equal 9? What happened? Did I mess up? Well, why don't we look back at the graph of this one? So that one was here. 1/3 x plus 6 and negative x plus 3y equals 9. Look at what they were. If you recall, they were parallel, which means we have no solution. So what that means in terms of when you go to solve it algebraically, you get, I call this a bogus answer, because 18 is not equal to 9. Bogus answer. They're not equal. That's not true. So when you get something that is not true, it means there are no solutions. No solutions. Oops. Because the lines are parallel. So anytime you get two numbers that are not equal to each other, negative 4 equals 6. No, it doesn't. 12 equals 11. No, it doesn't. 0 equals 15. No. Anytime you get two numbers that are not equal to each other, it's because you have parallel lines. You may want to double check again. Remember, you can tell if they're parallel lines if they have the same slope but different y-intercepts. So you could just rewrite this one in y equals mx plus b form and verify that they both have a slope of 1/3. And they do, as we saw when we look back at our graph, but that's what that means. Okay, so if you get a bogus answer, doesn't mean that you're wrong. It means that there is no solution, but just make sure you go back and double check. Okay, because, I mean, you may have just made a mathematical error, so that's why you want to go back and verify, or double check that they really are parallel. In this case, they are. Okay, that's the last trick question, I think. But if you do recall from the last video, there was, I'll show you the graph of this first, before we really look at it. And that was this one here. We had y equals -1/2 x plus 3 and y equals x plus 1. And when I graph them, I don't really know where the intersection point is. I know it's near 1.5, 2.5, but I really don't know. How do I know it's not 1.4? I don't know that by graphing. So we're going to solve this algebraically, and we can find out the exact answer. So I know about what it should be, but let's go ahead and solve this using substitution. Get one of the variables alone in one of the equations. I have that in both. Why don't I just take x plus 1, I'll plug it in for y over here. So I'm going to take x plus 1, and I'll pop it in for y over there. So I'm really going to do x plus 1 equals -1/2 x plus 3. I don't want to deal with the fractions, so I'll multiply the whole thing by what? Hopefully you said 2. So that will get me 2x plus 2 equals 2 times the -1/2 x is -1x, or negative x, and 2 times 3 is a positive 6. I have only x's left. I can solve. I'll add x to both sides. 3x plus 2 equals 6. Subtract 2. 3x equals 4. Divide by 3. Divide by 3. Okay, so x is 4/3, which is the same as 1 1/3. So I knew it was around 1.5, but it's not 1.5. It's 1 1/3. Okay, so now I know that x is at 1 1/3. I can take that and plug it in over here. 1 1/3 plus 1. Well, that's not so bad. That's just 2 1/3. So now I have my solution. Now I know exactly where it is. It's at 1 1/3, comma, 2 1/3. All right. Okay, and if I look back at my graph, we can verify 1 1/3. Okay, 2 1/3. Yep, that looks about right, because I knew it was in that ballpark, but there's no way. How would I have known that by just looking at that graph? So solving it algebraically was a great way for me to know for sure where it is. Okay? I hope this helped you solve by substitution, and take a look at the next video to learn how to solve by elimination.